folks, today we are going to focus on the pH concept. pH stands for the power of hydrogen, and that is a way that we determine how acidic or how basic a compound is in solution. So let's go ahead and dive on in. So you will be able to understand the concepts of pH and how that applies to how acidic or basic something is. I feel like I just said that. And then you should be able to calculate pH, power of hydrogen, POH, the power of hydroxide, the H3O plus concentration, which is the concentration of hydronium ions, and OH minus, which is the concentration of hydroxide ions. We got some couple key vocabulary terms here. Really just looks like a bunch of letters, but we got KW, pH, POH, concentration of hydroxide, and concentration of hydronium. So let's talk about water real quick. Water has the unique ability to self-ionize into constituent parts of acids and bases. So if we look here, two water molecules can spontaneously form an H3O plus ion, which is an acidic ion, and OH minus, which is a basic ion. Now, the concentrations of these in pure water are very small. It's 1 times 10 to the negative 7th moles per liter. Again, that's the same thing as molarity. It's a very, very small amount of concentration of this in solution. So we can write a formula for this. Because if both of them are 1.0 times 10 to the negative 7th, if we look down at the bottom, we can set that equal to, we can multiply those two numbers together and get 1.0 times 10 to the negative 14th, meaning that we have that is a constant value for water. So if we alter the concentration of H3O, we subsequently alter the concentration of OH as well. As one goes up, the other goes down. It's very similar to pressure and volume in the combined gas law, where as one goes up, the other goes down. We apply pressure to something, the volume of it decreases. It's the same concept here. We have higher concentrations of H3O plus, the OH concentration goes down, and vice versa. So alterations in the concentrations can be calculated if we know the concentration of one. So if we have the concentration of one, we can know the concentration of the other. So for example, it's asking what is the concentration of OH and H3O plus in a 1.0 times 10 to the negative second, big M, NaOH solution. Well, the first thing we need to recognize is that NaOH is a base. We know that because it has OH at the end of it. It is also a strong base, which means that it is going to completely break apart or dissociate into its ions. So if I have 1.0 times 10 to the negative second molarity of NaOH, I'm going to have 1.0 times 10 to the negative second molarity of OH ions because it all completely breaks apart. Well, then what I do is I just plug it into the equation I just showed you. In order to figure out the concentration of H3O plus, we plug in the concentration of OH minus. So what we get is H3O plus times 1.0 times 10 to the negative second equals 1.0 times 10 to the negative 14th. We divide, and as you know, when we divide, we subtract when we're talking about exponents. So the H3O concentration is 1.0 times 10 to the negative 12th. That's a very, very low concentration when you consider the OH concentration is 1.0 times 10 to the negative second. Therefore, this solution is going to be very, very basic. There are a lot more hydroxide ions than acidic ions when we put them into solution. These concentrations are on a base 10 system. You know, we talk about those exponents, the times 10 to the negative 11, the times 10 to the negative 12, and that's fine. But as a result, we can actually use some logarithms to put these into simpler terms. So we use the term pH rather than usually the concentration. pH, the power of hydrogen, is equal to the negative log times the hydronium concentration. POH is equal to the negative log of the hydroxide concentration. pH plus POH will always equal 14. It's very similar to the equation we looked at before when our hydronium concentration times our hydroxide concentration is 1 times 10 to the negative 14th. So we'll need to be able to do some calculations with these models. So before we move on, let's talk a little bit about this pH scale. Let's make scale the word of the video. That's right, you heard it here first, and probably for the last time this year. Scale is the word of the video. So the pH scale is based off of 14. Anything with a pH that is greater than 7 is basic. Anything with a pH that is less than 7 is acidic, and a pH of 7 is neutral. So for example, water would be neutral. Each number increase represents a tenfold difference. So for example, the pH of 5 is 10 times more acidic than one that is 6. The Richter scale works the same way when you're measuring earthquakes. A Richter scale, a magnitude of 7.0 is 10 times greater than that of a 6.0. It's the same concept here when we look at pH. So for our first practice problem here, it says to determine the pH of a 1.0 times 10 to the negative fifth molar LiOH solution. So the first thing we need to do is to identify whether this is an acid or a base. So if we take a look here, we got LiOH. That tells us that we are dealing with a base. Okay, so that's a good place to start. And remember, when we talk about bases, we're talking about OH minus concentrations. Now, lithium hydroxide is a strong base, so what that means is that 1.0 times 10 to the negative fifth molar solution of LiOH is the same as 1.0 times 10 to the negative fifth OH solution. Okay? So keep that in mind. Because it is a strong base, it completely dissociates and breaks apart, so the concentrations of those are the same. So there's a couple ways we can go about doing this. I'm going to go ahead and think about the formulas that we talked about before. Well, I do know that if I take the negative log of my OH concentration, I get my POH, power of hydroxide. And then I also remember that my pH plus POH equals 14. So I can plug this number in and get the POH and then plug in and solve for pH, right? So if I do that, my POH is 5. I plug in here and I get my pH plus 5 equals 14. Do a little bit of math. My pH is equal to 9, which would make this a somewhat basic solution. All right, that was pretty straightforward. Let's move on to another type of problem. It says here to determine the OH, H3O+, and POH of a solution that has a pH of 4. Okay, so we got to figure out all these different things. So let's think about what we need to do to get started. Well, I think the easiest one to probably solve for right now, POH, because we know that pH plus POH equals 14. So if my pH is 4, then my POH is clearly going to be 10. Okay? That's a pretty good start. Now the other two are a little bit tricky, and this is an equation I haven't shown you yet, but I'm going to show this to you now. You can do the inverse function of the log, okay? And it's really, really easy to go through and figure out the concentrations of hydroxide and hydronium. The formula is that the concentration of OH equals 10 to the negative POH. And it works the same way with H3O+. You can get that by taking 10 to the negative pH. Okay. So pretty straightforward. All we have to do is we just plug in some numbers here and solve. So this one we're going to set equal. It's going to be 10 raised to the negative OH, so 10 to the negative 10th. And this one is going to be 10 to the negative 4. Okay. And so when we finish and we write these out, we would say 1 times 10 to the negative 10, big M, and it's my concentration of OH. Same thing here, 1 times 10 to the negative 4th, big M. That's my hydronium concentration. So again, these are pretty straightforward to solve. Make sure you know and think about these two new equations we just went over. Okay? They will come in handy as we go through several practice problems as we move forward. All right, guys. Well, that pretty much covers all of chemistry for this year. Long story short, water can act as both an acid and a base depending upon what is being added to it, and we can calculate a variety of different numbers to express how acidic or basic a solution should be. This covers pretty much all of general chemistry. There might be one or two more extra videos I add on a little bit later on, but be perfectly honest, that pretty much covers it all. Wish you guys well in everything that you do moving forward. Best of luck as always. If you ever have any questions, feel free to let me know. If you're in class, you can always come and see me, or you can always email me, contact me through that medium as well, or through this YouTube channel. If there's anything else that you'd like to see, let me know. I would leave the comments open, but I'd be afraid of all the negative feedback I would get. But as I mentioned before, I thank you guys for watching these videos. I thank you guys for taking the time to be a part of my life. I've enjoyed being a part of yours, and hopefully you learned a little bit of chemistry along the way. All right, best of luck to you guys, and we will see you next time. Jayland Bio, for the last time, signing out. Goodbye.